Benjamin, and I will talk to you about how you can talk to the database using the Doctrine library. First of all, I'm very happy to be here, and I brought my wonderful wife, and we are really like Argentina so far. It's a really great country, so thanks again very much to Mariano for inviting us here. And I'm especially proud that delegates of Facebook and PHP are spying on this talk to see how you can implement a good database layer. And yes, I'm going to show you a little bit about what Doctrine does. First, a little bit about me. I'm working for a company in Germany called Capa, and we do software quality stuff and help people create great web applications. I'm also a developer of the Doctrine project, currently the lead developer, and oh wait, this was way too far. Yeah, this was the wrong button. I should maybe use another one here. Okay. So I'm also a contributor to the Symfony framework, and you can reach me on Twitter at Eberlei and the company Twitter account if you want. So what is Doctrine? Doctrine is a library that helps you solve problems with databases. And what are databases sort of in a big perspective? So initially Doctrine handled relational databases exclusively. And the version Doctrine 1 supported some relational databases, and currently the version 2 that we have has stable support for the big database vendors that you might want to use. So even for Oracle, we have support, SQL Server, and we also have some experimental support for some drivers such as Drizzle, DB2, and Sybase, but they're not really so stable, and I'm not really sure if they work. What we also do is, since we have libraries that work with databases, or the Doctrine project sort of tries to have lots of libraries that are related to databases, we also have projects that implement libraries for document databases such as MongoDB and CouchDB. And we have a library that handles a graph database called OrientDB. And we also have a pretty big cache library that sort of connects to many of the new NoSQL solutions using a cache API. So React and Redis, for example. So this talk will focus on the relational database side. And I will start with an introduction to the database abstraction layer, because mostly what people know about the Doctrine project is the object relational mapper. And this is the biggest library of the Doctrine project, but the database abstraction layer is actually very handy and very useful in many applications, and you don't necessarily need the object relational mapper. So the Doctrine database abstraction layer has many different features. The first one of them is an abstraction for different drivers. So we have a driver abstraction, and we have an abstraction for different dialects of the SQL language. So every database vendor sort of implements NZSQL and then more. And some of the features of relational databases are implemented in many different ways in the different databases. So then there's lots of convenience APIs. So instead of having to write SQL using like sort of big strings, there are lots of convenience APIs that help you use the database in a more simple way. And there's an abstraction for the different types that SQL provides. So every database vendor, again, has different types. For Booleans, for example, datetime types, strings, large text types, and all the different things. And this is actually not standardized at all. So NZSQL doesn't give any clue about what data types there should exist. So every database obviously has tons of different ones. And this abstraction tries to unify them to make it more simple to work with it across different databases. And then we also have an abstraction for schema generation. So if you want to define the schema of your database using tables, columns, foreign keys, all that stuff, there's an abstraction in the project that allows you to define this in PHP code, and it will be translated to the SQL of the database you're using. And I will show all these features in a little bit. The database abstraction layer in the first version of Doctrine was not independent of the ORM, so you had to use the ORM to use this functionality. But you can use it independently now since version 2.0, which was released about 3 years ago. So it's actually pretty old already. Again, let's start with the driver abstraction, which most database abstraction layers have to support anyway. So this is normally the first feature that any database abstraction layer has to implement. And it allows you to stop using low-level database APIs such as OCI8 for Oracle, PDO or MySQLi for MySQL, and all the different other drivers. The API is very similar to PDO. So we actually looked at the PDO API and took it almost one-to-one and used this API. But instead of using PDO directly, we sort of introduced our own interfaces for this, because otherwise we couldn't support something like Oracle OCI. PDO actually also supports Oracle, for example, but the driver is really bad and not supported by Oracle itself. And this is why you, in some cases, need to use the proprietary APIs that vendors provide for PHP. So what are the stable drivers that we support? So PDO we support with all the different backends that there are. MySQL, PostgreSQL, SQLite. Then we also support MySQLi and OCI8 I talked about already, and SQL Server extension. So I hope this is readable from the back. So if you have code that sort of uses PDO, for example, in this case, I have a very simple class that connects to a database and executes a query on some table. And when you use Doctrine DBAL, you don't need to use PDO, for example, in this case, but Instead, you're using the so-called driver manager class, and you call it a function get connection there and pass it some information, sort of like if you use PDO, you can do it as well. So there's a very, very simple abstraction to create this driver classes. And everything looks the same. Everything else looks the same. So you can execute queries, and this sort of, as I said before, looks exactly like PDO works. And this is essentially it for the first kind of abstraction. So what we could have done now using sort of this simple connect function is create connections for Oracle and all the different databases here and use this in our code. And the next step, so this is essentially not giving us much abstraction at all. We have like a simplified API or a generic API for all the different databases, but we still have to write exactly the correct SQL statements for these database types. So we really don't have much abstraction one here. The next abstraction level that we need is something that allows us to write the SQL in a way that it works on all the different databases. And the most important sort of functionality that all databases implement differently is the limit statement. So MySQL has the limit statements since for ages. You could like sort of say select something and then limit it starting row number 21, and I want to have 20 rows. And all the other databases didn't have this functionality before. So I think PostgreSQL had it as well, but Oracle, SQL Server, and I'm not sure. Yeah, those at least, they don't support this. What they need to make this functionality happen is actually use 3 or 4 nested subselects in each other and doing some kind of weird magic to get it working. And to be able to use the databases generically in your code to implement something that works with any database, you would need to have some kind of functionality to make this API looking exactly the same for all the different databases. And this is what in Doctrine we implemented as a concept called platform. And the platform has hundreds of methods, and they all allow to generate certain snippets for different SQL statements. And one of these is the limit query. And others are, for example, functions that you would use in SQL. So if you have an SQL statement that uses some kind of date converting, then every database has a different kind of function to do this. And we have this platform concept where we have methods that allow you to, for example, generate SQL to convert a datetime field to something else. And you can use this independent of the platform. So I hope you can see this, because even from here it's sort of small. So on every database connection, you can call the method getDatabasePlatform, and then you have an instance of this platform and can use methods on this. And our previous example had a pretty big query that's using the limit query functionality. And you would use the platform now instead and to generate it. So the method there at the top, it's called modify limit query, and you pass it the SQL statement without the limit query added itself. And this function will sort of use this SQL statement and make it to a limit query using a limit statement. And this works independent of any of the dialects. So this is pretty low level itself. If you would start using this and you would always use this kind of functions, it would be rather annoying itself. So we've won a little bit of abstraction, but it's not so nice to use at the moment. So how can we optimize on this? First, some kind of statements in databases are actually very similar. And these are the statements that actually manipulate data. Insert statements, update statements, delete statements look the same on all the databases, and there's no really difference there. One thing that is maybe different is that MySQL supports sort of joins in update and delete statements, and other databases don't. So this is some functionality that we didn't abstract, but because it's actually not really possible to generically convert a join statement into a subselect using just PHP code. That would be a huge undertaking, so we don't do that. But for most of the cases, when you do insert, update, delete statements, they're actually very simple. So we have a convenience API for them to create these statements for you based on arrays of key value pairs, column to value. So, and then the next thing is the SQL query builder, which can be used for select statements. And this, you will see in a moment, will simplify using, for example, the limit query. So inserting this function is very simple. The first argument is the table you want to insert to, and then you would just pass an array with all the key value pairs. The same for updating, but you have to add a where clause. Okay, this is an example of how the insert looks like in this case. So we have this insert function on our table that we created, and we just pass all the values. So you can see here, hopefully, that the last line shows how we generate a date. And we use this, in this case, we assume that we have MySQL because we know the format for MySQL dates sort of is like year first, then month, then day, then hour, and so on. So at this point, we haven't abstracted this kind of date handling here. But you can see using this functionality is sort of easy to generate very simple statements. Update is the same, using just an additional where clause that you can use as the third argument, and deleting is also the same. So the actual complexity that SQL provides is in select statements. Select statements are used for accessing data in many, many different ways. And this is one of the most powerful features of relational databases. And not having this functionality with a relational database, using some sort of library that prevents us to do this, is really annoying. So select statements allow us to do all the stuff that we need in our applications, and we want to use the full power of them. And if we want to write code that is independent of the different databases, then we still have to use some kind of abstraction. And the way to make this rather simple without having sort of lots of boilerplate code is to use a so-called query object. And we have this SQL query builder object where we can use a Fluent API to generate SQL statements. And in this case here, you see we use two functions to set the first result and set the maximum result. So this internally will use the modify limit query functionality of any database platform to generate the correct SQL for using this. And using this feature, it's actually much simpler to write SQL statements that are independent of a database. If you need this for open source libraries, for example, or if you're not sure yet for your project what database you want to use. Using just this functionality I've shown, we can start and create simple abstractions already. So we know that we have tables in our project. So we could go and create some class called table and use some generic methods, abstract method for the name of the table to create some code for inserting, updating, maybe simple finder methods or simple methods to create a query builder for exactly that table. So it's really simple, starting to implement some functionality on top of the Doctrine database abstraction layer that helps you a lot already with your SQL code and prevents you from having to write all this like in very much detail. So the next thing that we have seen is, I've talked about this already, the different types that exist in different databases. And since ANSI SQL does not standardize this, for Doctrine and the object relational mapper, we needed a way to make this the same for all the different databases. So if you use the object relational mapper, you have some database, you want to define some database types without having to think about all the details about the different vendors. For example, Oracle does not allow you to create a string which is larger than 4,000 characters. While MySQL allows you to do this until, I think, much higher numbers. Even more, is it just 65,000? It might be even more if you use a specific type. So this is one example, but there are many more, for example, like date conversion or Booleans, which some databases don't even support at all. And you need some kind of abstraction for this to make them similar. And this is what the type extraction does in Doctrine. So the Doctrine type API allows you to convert any PHP type into the type of the SQL database that you're using, and vice versa. So when you fetch the data from the database, you can use this API to convert it to the corresponding PHP type. For example, convert a date into a PHP datetime object, and converting the datetime object back to a string of the database. And we do this for quite a bunch of different types. So obviously we support sort of like strings and long characters, which are the most important stuff in web applications. But then numbers, of course, decimals, floats, any kind of datetime with or without time zones. Although databases don't really support time zones, they only support offsets, which is sort of annoying because offsets might change in a time zone if summertime starts or not. So this is not really good abstraction in any database. Then blobs are supported, Booleans, and you can even add your own stuff and use it. So there are people using this with PostgreSQL geotypes, for example, to allow you to convert anything that comes from the database into a point object, for example. You have a point in the PostgreSQL database and you have a simple point class in your project and you convert between them. And this is necessary if you want to implement something that works with different databases. And the ORM is actually one of the primary targets of this functionality because we want to implement the object relational mapper in a way that you can use it with any database that you want. So how does this look like? You can access the types from the type system calling a method getType using the name of the type, for example, datetime in this example, and then just start calling the methods to convert between the one and the other world. And in this example, it shows how you can convert a datetime instance to the string field in MySQL, for example. So the example here shows you need to pass the database platform to all these methods because the conversion actually depends on the specific database platform. It might change depending which database you use. So if you have this type abstraction for your code now, then the next question is, how do I actually generate a database schema from this? So I have a sort of abstraction for types now, but obviously in every database, the type generation mechanism is very, very different. So ANSI SQL, again, does not really standardize how you create tables, alter tables, and all this. So this is very complicated in many different databases. And it's also very annoying to keep this in mind, how this works. So to simplify this, and the ORM, again, is the primary target for this functionality because they use it internally quite a lot. We have this API to abstract database schema generation. And there's a simple object-oriented API that allows you to create a graph of your database schema, including tables, columns, foreign keys, and indices, for example. Sequences are also supported, and we are thinking about adding triggers and view statements as well. So if you have this object-oriented representation of your database, then you can actually start working with this. And we have functionality that allows you to compare two versions of the database schema and generate statements for your database that allow you to go from the one version to the other version or show you what the actual differences are. So if you have code and maintain this database schema somewhere, for example, if you say I have this and that tables in code, then you could write a little statement that allows you to look if the current database that you have actually implements this database schema, and if not, what statements are necessary to get there. How does this look like? So the API is very simple and works with exactly the same names that we have in SQL schema. So you create a table instance, and using this table instance, you add a column as much as you want. Then you set a primary key, you add a foreign key, and all this works rather simple. And using this, this was right. So you can easily use this using the so-called schema manager. So again, on the database connection, call a method get schema manager, and this method will allow you to do stuff with the object-oriented schema, with the schema objects. So if you have a table object, we can pass this to the create table method, and it will generate the SQL statements necessary to create the table and then execute them directly. So creating a table normally needs more than one statement. You need the create table statement, and then you need some alter table statements to generate the foreign keys and the indices. You can't normally do this in just one statement. So what this schema manager does is abstract all the different kinds of stuff that you need to generate here. For update, it looks a little bit more complicated. So there's this comparator class, which allows you to compare the two different schemas or two different tables. And you can fetch the object-oriented representation of your current database for a specific table. And then you can generate your own in code. And then you compare them if they look the same. And if they don't, you can just iterate over the SQL statements that are necessary to generate, to go from the one to the other schema. And this obviously depends on your database platform again, because for every different vendor, this SQL looks very different. So these are the sort of 5 different abstraction layers that the Doctrine database abstraction layer provides. You can use them in your project to sort of, if you don't want to use the big object relational mapping library, or you will use all of them if you use the object relational mapper. And because the object relational mapper is actually the library that uses all of them or needs all of them to work. What is the object relational mapper? It's sort of our biggest project, and it's sort of a very complicated project as well. It allows you to map any PHP object that you have to a database table and back. And saying it allows you to map this sort of sounds rather simple, but the mapping is actually very complex. Relational databases and object-oriented models are very different representations of data structures, and they don't match so well. So at first you might think, okay, obviously one class to one table, and then one column to one field in the object. But once you go to like relations between objects, it's going to start getting very, very complicated. There are many different things you have to think about. How does this work with relations? And then maybe you come up with the idea that you want to map 2 columns to one field, or many different other things. You want to have arrays with key of values or something like this. There are many, many different functionalities that you might want that are really hard to implement in a generic way or in a good way. And it's a tricky thing to do. And this is why the ORM is actually very complicated to solve all these problems. And it helps you manage, for example, associations between different objects and many different functionalities as well. What it also does is, if you're using the object relational mapper, then you can use the schema abstraction to create the tables necessary for the objects that you want to have. So you define objects in your project, and you say, okay, these should be saved in the database, and then the ORM will look at the definitions of these objects and generate the tables necessary to make this work. Object relational mappers are always sort of a leaky abstraction. What does this mean? Because I said before that it's actually very complex to do this, object relational mapping. It's not possible to hide all the different details of relational databases from a user of an object relational mapper. And it would be very dangerous to try this. So many object relational mappers allow you to use associations between objects in very simple ways. But whenever you do this, there are actually SQL statements executed in the background that you don't really see. And very often this leads to very inefficient code that, for example, generates SQL statements in a loop. So everybody knows pretty fast you should never execute SQL statements in a loop. It's very inefficient to do this. You can optimize queries to be much more efficient instead of re-executing a query all the time. But once you give developers an object relational mapper, they don't see the SQL being executed. So they use all the stuff, and it looks very nice, it's very simple to use, and you get very inefficient solutions because they execute SQL that is very inefficient. And this is a problem that is very hard to solve with an object relational mapper. And you as developer need to know about this problem to use this correctly. If you don't do this, you will build very slow applications. Normally in development, you won't realize this because you have not enough data to actually cause the problem to be slow for your development environment. But once the application gets larger in production, this can actually hit very hard and makes the sites very slow. Then, obviously, converting objects, or now we're converting data from an SQL database, relational database, to objects is adds a performance penalty to your application. Because this mapping can be quite complex, this can also be quite a large performance penalty. And for very high load websites, it's often not really good to use a complex ORM such as Doctrine, which allows you to do many different things, because maybe you don't need all the stuff and maybe it's a little bit too slow to do this. So Doctrine itself is not super slow that you wouldn't use it in any use case, but for very high load applications, I've heard from people that they have problems using it because it adds a little bit too much milliseconds to each request. So there's always sort of, you have to weigh using something so big as an object relational mapper. It allows you to add a very, very powerful abstraction to your project, but obviously this might have downsides as well. So you have to think about, is it worth using something like an object relational mapping abstraction or not? So in Doctrine, there's a little bit of terminology I want to tell you about. So PHP objects that are saved in a database are called entities. And this means that the object is identifiable across many different requests of your application using some common identifier. And this common identifier is obviously the primary key in the database table. And you can always, in every request, say, I want this object using this primary identifier. And Doctrine implements the so-called data mapper pattern. That means that you don't have to extend any base classes with your PHP objects or any interfaces. The objects that you implement don't really use any Doctrine API. They are just very, very simple PHP objects. And then Doctrine will look at these objects and get all the data from them using PHP functionality that allows you to do this. If you write a generic database abstraction, object relational mapper, like we did with Doctrine, then we don't know how your applications look like. So we have to provide some API that allows you to explain to Doctrine, my objects are these and that, and they map to this database tables and these columns. And this is requires some kind of configuration for all the projects. And you have to do this kind of configuration when you use an object relational mapper that is generic, such as Doctrine. And Doctrine, here you see a simple class that we want to save to the database. So we have a post object with ID, title, and body properties, and it shall be saved in a database table called post using ID, title, and body columns. So it's a very simple mapping. The table has exactly the same name as the class, and the columns also map to the database in a very simple way. So how do we tell Doctrine that this is actually the object that we want to save and how we save it? We do this using so-called metadata configuration or metadata mapping. And this is possible using several different configuration mechanisms. One of them is using doc-block annotations in PHP. And the other ones are, for example, XML, YAML, or you can also write this in plain PHP code if you want. And this mapping defines to Doctrine how this object post is saved into the table that we've seen before. And you have to define this for all the objects that you want to save with Doctrine. How does this look like for associations? So associations or references in databases are foreign keys. So I have a a primary key of some table, and I reuse the same primary key in another table to allow me to join between these, or to define a relationship between these. I don't necessarily need to join them, but I have this primary key duplicated in several tables to show how the association works. And Doctrine translates this in the PHP world to references between objects. So instead of having to work with the primary keys and setting them in the different values, you would actually connect the objects using their references. And then when you save this to the database, the references are converted into the foreign keys and back. So you don't ever have to work in detail with the foreign keys. Instead, you work with the references between objects. So foreign key management is not really necessary explicitly. Instead, you work with the references. There are two kinds of references. One is the simple N-to-1 or one-to-one reference, where one object has a reference to one other object, which is a very simple foreign key. The second reference type is the other side around, when one object knows how to access many different other objects. So a blog post can have 0 or 1 or many different comments, and this is a collection of references to other objects. How do we define them? In the metadata mapping, again, we say something like, this is a many-to-one association. And we define what other entity is the target of this association. So you have, for example, a blog post object, and there's always one author that authored this blog post. So we define a many-to-one association to an author entity or a user entity, and Doctrine knows how to turn this into this foreign key relationship that exists in the database table. So there are some defaults how this mapping converts to a foreign key. In this example here, Doctrine would expect an author underscore ID column in your table. But if the column is named differently, then you can be more explicit about the mapping and say, no, this column is not called author underscore ID, it's called maybe anything different. And explicitly state, this is the different name that we want to use. So there are some very simple defaults for the different kind of mappings that you can do. But whenever you want to change them and you have something different in your project, you can also be a little bit more explicit and change more. The second case of references is the so-called collections of objects. You would, again, go and define them using some metadata configuration. In this example, one-to-many, and we're connecting to some comment, for example, in this slide. So the blog post has many comments. Until now, we haven't actually seen anything Doctrine-related except the configuration. So we had some configuration, and we had some very simple PHP object. How do we actually save this in the database? So there's this class, or this object in Doctrine called Entity Manager, and it has access to all the public APIs that you want to use. It has public APIs for saving, loading, and many different other functionalities, like transactional APIs, for example. We are able to add and remove objects from the database using this entity manager. And what we implemented here is a separation between the notification about this is a new object or I want to remove this object, and then the actual transaction. So instead of doing this directly when we call save this or remove this, we always schedule operations. And then you have this explicit functionality as developer to synchronize all the operations in a single transaction, for example, at the end of your request. This functionality allows us to be much more or much faster with the operations. So when you schedule operations and batch them, instead of executing them directly, you can optimize a lot more for for example, transactions or batch APIs of the different databases. One thing that is always sort of like amazing to people that don't see this or haven't seen this before is opening a transaction for write statements or a route around, for example, insert and update statements actually increases the performance in any database by very large margins. So not because whenever you don't do this, do multiple insert statements, multiple update statements, and they are not wrapped by a transaction, every database will implicitly create a transaction and commit the transaction for every statement that you execute. And once you wrap a transaction around them, this will only happen once. And databases can optimize a lot for the actual I/O write statements that have to happen when the transaction is committed. And this makes the operations much, much faster by batching different write statements. So, yeah, I have one use case where we didn't actually use Doctrine, but something else where we could cut a batch job from hours to several minutes just by adding a transaction around that. So, when we have our objects and we have the entity manager, how do they actually connect to each other? So, if I have an instance of this entity manager, I call the persist method, which is the notification. This is an object that should be saved in the database at some point. So our post or user objects, we can just pass them to the persist operation, and the entity manager will know whenever I commit a transaction, these objects should be included in this transaction. So how do we execute this transaction? We call a second method on the entity manager called flush. So all the outstanding changes to the database are executed and the objects in memory and the database look the same again. It's sort of a synchronization between the state of the objects in memory to the serialized format in the database. If we have saved our objects to the database, then we obviously want to find them back. So the next request needs the object again. So how do we access this? There are some very simple APIs to find objects by ID or by key value pairs. However, this kind of API is very lacking very fast. So I told you before about SQL or select statements being very powerful. So very fast in any project, we want to execute something much more complex than just finding objects by ID or by key value pairs. The next API that allows to do this is the criteria API, which allows you to add more complex comparisons, not just the equal comparison, but also like bigger, smaller, or something like this. But this is not enough in most cases as well. This is why we added something called the Doctrine query language, which is something looking very, very similar to SQL, but it leverages all the power that we already use in the Doctrine project with all the metadata mappings that we have defined. So we have defined all the different associations already. So it is actually not necessary for us to do the on clauses for joins, for example, because we already know how they are looking like. And I show an example of how this looks like. So the first case, finding objects by ID, on the entity manager again, because it's the access point to all our operations with Doctrine, we can call the find method, pass it an object name and an ID, and it will return the object. Or if the object doesn't exist in the database, it will return null. So very, very simple. The next API using some simple criteria, it's using a concept in Doctrine that we call repository. Each class or each entity has a corresponding repository class, which has a bunch of methods to allow you to find objects using key value pairs, using criteria, and many different ways to get access to objects. But this, as I said, is sort of not very powerful as well. You can do some use cases, but not so complex ones. So we want at some point to use the query language to do this. why do we need an extra query language? First, obviously we could use something like SQL. So there's an API that allows you to use native SQL and turn them into objects that you have defined before. The problem, however, with this is that you have used this metadata mapping. So at one point you defined how this all works, but when you want to, once you start writing SQL manually, then you have to duplicate all this information to this select statement. So a select statement for this object requires all the columns that you want to fetch and all the table names, and you define the joins of all this information. And doing this in many different places in your application is actually a duplication. So you're duplicating the same information over and over again. And probably you know cases where you want to change the database schema of something, and you have so many select statements like used across the whole project that it's really hard to change all of them to make it work. So using select statements at many different places and writing them is a really problematic duplication in code. So how do we prevent this, since we have this mapping at one point? We prevent this by using this mapping for writing queries. So instead of defining all this information over and over again, we are having some central point where we have this information and generate SQL, or most of the SQL statement from there using a much simpler query language. This query language also doesn't speak tables and columns, because we have defined our objects and their fields and all that. It's much simpler in our application to write the queries in terms of I want to query this class and this and that field, because then you don't have to translate all the time between your object that you're using and how they look like in the database. So you have the objects and you can write queries in terms of the objects, and since we have this mapping, it will be translated to how this looks like in SQL. And because building your own language in PHP is actually a very bad idea, we designed this in a way where this is cacheable at every step. So defining this Doctrine query language allows us to translate this to SQL statements and then cache this whole process. Because otherwise you would have a parser inside your PHP process for every request all the time. And if this would be like sort of complex queries you're executing, then the parsing process obviously is also complex and takes lots of time. And you don't want to do this because it makes the site slower. So we designed it in a way where it's completely cacheable. And how does this look like as an example? I hope you can see this. So the language looks the same like SQL by having keywords like select, from, where, group by, joins, and all this. But since we have the metadata information, we can skip most of the annoying parts to write. So in our case, for example, the select statement only uses the alias of the class, P. So we define from our object post and give it an alias P. And then we say we want to select this alias P. And Doctrine then knows that this means I want this object and it has all these different columns, and it generates an SQL statement with all these columns. So you don't have to explicitly say, I want this column, I want this column, I want this column. But it says, okay, you want them all because you want your post object. Also in this example, you see a join. So the joins is simplified because we have defined the relationship, for example, between posts and comments already. We only need to define, say to the query language, please do a join over this association. So post has comments, so do a join over this association. And the metadata information already contains what table is affected, how the foreign key looks like, and this simplifies writing joins between two classes. And the query language also has functionalities such as group by, having, and all this. All the powerful features that SQL provides to you, so that you don't have to sort of hack around the object relational mapper. Some object relational mappers that have very simple query APIs prevent you to do something more complex. And then you have to start, for example, iterating over the objects in your code because there's no simpler way to do that. And this might be very inefficient when the database can already group by them or order by them. So the query language is very near to what SQL provides because SQL is so powerful. And we have chosen SQL as a database or SQL as a dialect for relational databases because it's so powerful to access data with it. So using an object relation mapper shouldn't make the possible queries it shouldn't prevent us doing this complex queries by the way it is designed. So this is how in Doctrine you can do this more complex queries. And you have seen quite a bit of different APIs now from Doctrine, the database abstraction, and the object relation mapper, but there are several things more that I don't want to show here. So there, as I said before, mapping objects to relation databases has very, very complex edge cases and different stuff. And we, as a library, sort of implement several of them. We don't do everything because it might make the project very, very complex, but we try to implement most of the things that you might want to use. And you can look up in the documentation what all the different features are that we are supporting. Okay. This was the talk. Do you have any questions?